Okay, Eric, this fan suffered some damage in shipping. I got it out of the box and started working on it. Excuse me. And as you can see, the blade guard here has got bent in and then comes back out. And you can see that the blade, I already tried to straighten it as much as I can and get the blade. It was actually stuck on the blade guard. That's what happens with fans when they're shipped with the blade and the blade guard on. Anyway, lately I've been telling all my customers, because of shipping issues like this, to remove the blade and the blade guard when they send in the fan and put them in a separate box. The blade doesn't seem to be too bad. It's a little bit out, but I can straighten that. I can't do much with the cage. I'll do what I can. I can only do a little bit without, I don't have a machine shop. So the issue is if I push too hard, I could pop the weld joints on here. Then it has to be re-welded. But you can see by this one here, I wish this was a little straighter, but I'll tilt the camera a little bit. So you can see by this one how it bends back and then comes, goes toward the motor and then comes back out. Same with this one. But this one, if you look at the space here, and you can see it gets really tight, and then it comes back out. So even this back bar's bent some. Now, I don't know, this might have been the way you got the fan. I know you say you bought it online. I wouldn't imagine it was bent that bad that it was binding and you wouldn't tell me. So I'm assuming it wasn't that way. And it got that way during shipping, and that happens. Electrically, there's something else wrong. It's not just the blade. I mean, yeah, this should spin, right? And all I did was straighten it out so it wouldn't rub. I'm not dealing with the cage till the end when I go to assemble it back. But that should be spinning, and it's not spinning. So if I plug it in, okay, let's see. I'm at 120 volts. But let me see what we're rated here. 110, 120 volts, 60 hertz at 0.8 amps. Okay, so I'm at 120 volts, so it should definitely be around 0.8 amps. Now if I put it on high, you hear the rattle. Now, I don't know, I'm sure you're hearing the wind. I did get it oscillating. I had to redo that. So there's some rattle, and that's the aluminum blade being out of, it's not hitting anything, it's just rattling from air pressure. Oh, that was a little bit of a nick. Okay, so at 120 volts, it's drawing 0.8 amps. Now if I go to low, you see what happens. It stops. Well, it's about to stop. There it goes. And it's drawing 0.67 amps. So it's not the current. Of course, I got to shut it off because it's drawing current and not turning, it'll overheat. But, so anyway, I got to take the motor apart, and I'm going to work on that now. And I just wanted to show you the condition of the front of the fan. The oscillating arm seems okay. It doesn't seem to have any bends. I did get it on there and put some oil on, and that's working. And I worked on the gearbox a little, but I wanted to make this video so you could see that. And of course, it seems to be turning fine there. So I'll see what I can do to get the... that's fine. It's nice and snug. So nothing really got hurt. Now I have been adjusting it, moving it around since I got it on the bench this morning and out of the box. To get this going, clean out the gearbox. I did all of that kind of stuff. I just need to find out what's going on with the motor shaft. It doesn't seem to be warped because the blade's not wobbling. It's just the blades are out of kilter. So I'm going to deal with them now and try to straighten this out a little bit. When I send it back, I'll be sending back the blade and the guard in a separate box. If I can get them in the same box and put the smaller box with the blade and the guard on top, lay the motor down and put the other one on top, I'll do that. If not, it'll come in two boxes, unfortunately, because I don't want this to happen again, and I don't want it to get worse. Shipping has really become a problem, and it's not a matter of how well you pack it so much as how it's handled. This is a heavy motor, heavy base, very delicate and lightweight fan blade and grill. And so if they lay it down fast, the weight of the motor pushes against the cage, and if it's on something, it pushes back, right? And that causes this. And so that's what happened there. Again, it might have already been slightly bent when it was shipped the first time, and so that even made it, more sensitive to shock wave. Now I tell all my new customers, I think I got it on the website as well. I think it's been there for quite a while. Take the blade and the guard off, and if they can't, well, then they really need to get someone that can because of the risk. Again, this looks pretty good. It just needs some work. So I just wanted to make you aware of what we got going on, and I appreciate your patience on me getting to this. It was beyond my control, but I am working on it now, so I'll do my best, and I'll keep in touch. Thank you. Okay, continuing this video. I'll put it this way. I went ahead, took the plate off, and right now I'm on the low speed. And so that goes through this coil. This is a choke called a choke coil. They call it a speed coil in fan restore, but it's actually just a choke coil. That's what it does. It drops some voltage. So basically, when this is in high, the line cord here comes in here. One side goes directly to the motor. This side here goes up through the head wire directly to the motor. The other side of the line cord coming in is this one here. And so this one, when you got it switched to high, goes directly to the other side of the head wire. So basically the two wires coming in from the line cord are then directly connected to the motor, and the motor runs full speed, right? Because the power is coming directly from the outlet directly to the motor. So that's full power. When you put the switch in low, okay, what happens is then the electricity, instead of going directly to the head wire here, goes through the switch, comes in this choke coil, has to go around this coil, which is a magnetic creates a magnetic field and resists the electricity. So there's a voltage drop here. So we have 120 volts going in, right? And there's a voltage drop across this, should be a couple volts, and maybe 10, 15 volts. And then it comes out the other side and goes to the head wire and directly to the motor. So even though we got 120 going in, when it goes through this coil, we'd have about 105 or 100 or 95 going to the motor, which would slow the motor down because it runs on high at 120 volts. You give it less, it's going to run less. Okay, so we should have around, probably 10, 15 volts across this. Okay, so now I'm on low. I got my meter connected across this so we can see exactly how many volts are across this. So now when I plug it back in, the switch is in the low, so it's going to go through this coil. When I plug it back in, the fan doesn't turn. There's voltage across the coil, and look at how much voltage. So it's 43 volts. Now if I spin the fan and try to get it to turn, that'll fluctuate a little bit. You see, it moves a little, but not enough. So we got a bad coil here. And I also know that because I've got a current limiting bulb on, limiting the current. So basically that light should be pretty much out. Should be very dim, if anything. And the motor would be spinning. But because that light's on, that means there's a short somewhere. Well, the short is this coil. So if I unplug it, and I'll show you that, and I switch it to high, okay, I'm still measuring across the coil. This should be absolutely, it doesn't matter, right? It's not being used, it's being bypassed, but there'll be a little bit of residual voltage in it. So if I plug this in, now I'm on high, and spin the motor. Well, you see there's no voltage across it. The motor won't spin because it's taking too much current. If I put my light out, there it goes. Okay, so we got 0.72 amps, and it's rated 0.8, so it's actually running really good. The motor sounds good. And we got no voltage across the coil. So now with the light out, I'll do that again. I'll put my wire back on. It's hard to switch this switch one-handed. It's a tough switch. Hold on while I get that set. Okay, I got it connected back up. And actually had to kill the video to do it. Alright, so now I got my light off. So now full power, there's nothing being eliminated, is going to the low speed on this, and I'm still across it, I think. And yeah, see, 48 volts. Now with my light on, current limiting on, it was limiting the voltage through this coil to about 46 volts. So anyway, 48 volts. All right, so we're at 120 volts. Subtract 48, or say 50, from 120, you got 70 volts. The fan motor will not turn on 70 volts. So this thing is using up way too much current. And so that's why it's actually warm. That's why the paper's all crispy, and you see this has got loose. You see how crispy that is with age? That got hot for a long time. So this fan has not been running on low for a very long time, or if it was running, it was just barely crawling. It might have been like, say, 27 volts, which would be enough to make the fan turn slow, but this thing would be getting hot doing it. Well, you know, it's not shorted. It didn't break. It didn't burn up. It's just, well, it probably is got a couple shorted turns, but it didn't burn up. If I go to resistance, now that I got it unplugged, and of course now I'm measuring across this and across the motor, but if I go to resistance, we got 0.8 ohms. If I shut, 7.9 ohms. If I shut the switch off, now I'm only across this. I'm measuring the current across this. There's no return path any other way. It's only through here from the black lead to the red lead of my meter, right through this coil. It's the same thing. So it's 8 ohms. Well, if you take 100 volts and you divide it by 8 ohms, you're going to see that, if you got 80 volts and you divide it by 8 ohms, you got 10 watts, right? You got 10 amps. So that means all of the current is going through this. This thing should be rated somewhere around 20 ohms, 25 ohms, not 8. So it's definitely shot. Now, the question is, what do we do with this coil? If you want low speed, the only thing I can do is buy another coil, and I'd have to find one, or rewind this coil. And I don't know that this coil is salvageable to be rewound. It probably could be. What makes it difficult is they riveted this side. I'd have to drill that rivet out, and then there's spaces like this one here. See this piece here? There's one of these that goes across. It doesn't go all the way around to the other side. It just goes straight across from here to here. And it's like how it's cut here. It's cut the same way there. It's just this piece. And that goes between the plates, between every other plate all the way through. And on both sides. There's one here, but they're shaped like this because they go all the way up to this screw here. And that holds it together, right? This side's riveted together. All of that would have to be taken apart to get this off, to unwind it and wind it again with new copper wire. Now I have a winding machine, but that would be quite expensive labor-wise to do. It would be much easier just to find another switch. The third option would be, of course, run the fan on high and not have a second speed. That's not acceptable. I understand that you would want, I'm going to take these wires off here. You'd want that better. Now I checked these because I was thinking, well, maybe they crimped these and they didn't solder them. And no, they didn't solder them, but they crimped them really well. So that's not the problem. That's not where the resistor's coming from. In fact, this one is just the wire itself wrapped around there. It doesn't even have a tab like these red tabs here. So, that's connected fine. I'll double check. I'll unscrew these, obviously, to take the coil off, and then I'll check directly from wire to wire. But I can tell you right now, that's not the problem. It's this. It's obvious. It's obvious this is all dried up. You can hear that, how crinkly that sounds. That was paper at one time with shellac on it. It said this is the shellac peeling off, see? And I can spray new shellac on it, but that's not the issue. The issue is the winding itself. What it is a bunch of coils, makes an electromagnet. That's why they have the metal rod going around it. It's just a bunch of coils. Well, when they get hot, they get old, right? The insulation on the copper wears off. And when it gets hot, some of the loops touch each other. They're not supposed to touch each other. They're insulated with shellac. All copper wire is. And so, all wire in a coil is. And so, when they touch each other, instead of the electricity having to go around the coil however many times, it may be shorted from here to over here, which may be like 50 loops of wire. So instead of going around that 50 loops of wire, it just jumps across. Well, that drops the resistance down, and that's why we're seeing low resistance. So when there's low resistance, it's just like with my light bulb. My light bulb is very low resistance. So even when this is in high, and I turn my light bulb on, I turn the fan on, you see it starts right up. You hear it. But if I turn the light on, see, and the motor stops. That's exactly what's going on here. That light bulb is very low resistance until it gets hot, lights up and gets hot. It's a regular incandescent bulb, right? So all the electricity, instead of pushing the motor to turn the motor, which is a lot of work, it goes through the simple path, which is go through the light bulb. and don't even go to the motor. And so, again, the voltage drops. Now here, you wouldn't notice it. I mean, well, you did. Okay, see what happened? So it dropped from 120 down to 70. It dropped 50 volts. That means 50 volts is going to the light bulb because it's so much easier, and only 70 is going to the fan, so the fan don't run. If I turn the light off, take it out of the circuit, the voltage comes back up to 120. It all goes to the fan runs. That's the exact same things happening here. This is supposed to subtract a little bit of the voltage to make the fan run slower. But instead, it's acting just like that light bulb. It's taking about 50 volts out, which means only 70 is getting to the fan instead of 100 or 95. And 70 is not enough to run a fan. Okay, that's probably overkill, and I apologize for that, but I wanted you to understand, how this works and what it does and how the speed is controlled by this coil. And so we know that the coil is the issue. The fan is in great shape. It's running fine, spins okay. Well, I shouldn't say it's in great shape. It's in really good shape. I'm still going to have to take the armature out and try to loosen that up a little bit. But, yeah, it's in pretty good shape. It's spinning fine, and it's not too loud when it's running. So that's good. So issues are the speed coil is bad. That's the low speed issue. The motor needs some adjusting so that it turns a little bit freer. The oscillation's been fixed. The fan blade, I need to put the fan blade on the motor once I get the motor spinning good without the guard and run it and see what blades need adjusting and try to adjust them. Once I get that done, let's see, maybe you can see here. Let me get these wires out of the way. Okay. Yeah, you can see here, I think. Actually, that ain't bad. See how high it is off there? That's okay, but they should all be the same. See, that one seems higher, and that one seems a little bit lower, and that one is really low. So this is the one that got smashed into the grill in shipping. And the other way you can see that is here. See how rocky it is this way, but not this way, just these two blades, because this one's bent up. These two are touching. Here and here are touching. So it won't rock that way. This one is touching here. Now it's touching here, here, and here. Almost touching here. But this one's off the table. So it's bent back. That's the one that got bound. See? So I can bend that back down and get the angle the same and get rid of a lot of that whining noise when it's running. It did, it twisted this a little bit, but some of that's been old damage. That's old there. That's been like that. In fact, that might have been even from the factory where it's twisted there and like overlapped over itself. See, this one is just like sanded down. That's the way it probably should be. Sanded down, twisted and overlapped. But that's not the one that's, that's not the one that's high. So anyway, this one here is the one that's bent up and needs to be bent back down. So that this is straight up and down and all four blades are touching the mat. That's that issue. I got to take care of that. The other issue is the guard, which I showed you the side view. Now I'll show you the top view. Notice how this is almost a perfect 90 degree angle here. It's actually a little less, right? It's bent in, so it did get bent some. That should be pretty close to a 90 degree angle. If we turn it around, look at that one. It's bent in. See? Should be straight up and down, and it's like that. This one here. And then this one is the worst. You see that? That's the one that got bent. So when you turn it over, you see that's where it's bent. So that's got to be straightened out. And then this needs to be pulled up, and I got to do that without breaking the solder joint free, or it'll have to go in the shop. Here's where the fan blade hit the metal on the inside. Well, that hit something. It didn't hit the fan blade. I take that back. The fan blade's in here. Something hit that. It probably hit the motor somewhere, the motor cage, when it got hit. But that's the one that got hit the worst. And so probably around there is where you see where the blade hit. Let's see. Yeah, right there. See it? That's where the blade hit. And so it got bound in right there. See a piece of paint just flaked off with me just rubbing on my finger there. So it got bound and the blade hit there and it bent the blade up. So all of that's got to be adjusted. You also see here, see where the paint's flaking? Let me see if I can show you that there. See that? Right there? That's from the same bend in that area there. It's minor. I mean, you'll never see it. There it is. I just knocked it off. And there it is. So You know, those are minor. I mean, this could have been tragic. This could have really been tragic. But that's got to be done. So that's the issues. This is the biggie. That's the second biggie in the motor, and then this is the next issue. But as far as time and expense, this is going to be the most expensive fixed. If one of these weld joints lets go, that would be the second, because then I have to take it to a welder, and it's aluminum, so it has to be, it may not be aluminum, maybe metal, but either way, it's got to be like spot welded, right? And of course, that has to be done in a welding shop. Other than that, it looks okay. You know, the paint job looks fine. It didn't really hurt anything other than it bent it out of shape. Now but that is one other issue. Is since the paint is flaky a little, when I go to straighten it, it could flake where I have to bend, you know. I mean, there's nothing I can do about that. And I will be as gentle as I can, but that's why it's going to go back in the second box. So anyway, I am sorry it took me so long to get to this fan, but I'm making good progress. I'm finding out what's going on, and got the oscillator working, the motor's running. I do need to get the motor running a little bit smoother, so I got to take it apart and see why it's not spinning as good as it should. It's not bad, it's just not as good as I would like. So I will take it apart and do that and get it optimized. It's fully oiled and greased in the gearbox. It's all been re-greased, so that's fine. And everything else is working good electrically. So anyway, I'll be in touch. I just wanted to give this update. Thanks for watching.